Alright, welcome to this video where we'll be going over the 2012 AP Calculus exam. So this first question, we have the temperature of water in a tub at time t is modeled by an increasing twice differential function w, where w is in degrees Fahrenheit and t is in minutes. Cool. Time t equals 0, temperature is 55 Fahrenheit. Cool. The water is heated for 30 minutes at t equals 0. Okay, so you can see the temperature is going up. That makes sense. Values of w of t are shown in this table. Okay. So part A asks us to use the data in the table to estimate w prime of 12. Okay, so let's figure out w prime of 12, okay? So we don't have a function w that we can actually take the derivative of to find w prime of 12, but we do have these 2 points which are close to which are close to 12, right? T equals 12, t equals 9, and t equals 15. So if we find the slope between these 2 points, we can use that to approximate the slope at t equals 12, okay? So the way we're doing that is we'll say, all right, w of 15 minus w of 9 over 15 minus 9. Okay, what's w of 15? That's 67.9, and then 61.8, and 6. And if you put that in your calculator, you get 1.017, right? So this is an approximation for w prime of 12. And now we need to say, okay, what does this mean, right? So let's think about it. So w of t, that's telling us the temperature of the tub, right? Temperature of the water in the tub. So then w prime of t is telling us, okay, how is wt changing? How is the temperature of the water changing, okay? So w prime of t is telling us the change in the temperature of the water. So w prime of 12, this will tell you that the water in the tub at time t equals 12 is increasing at this rate. And in terms of units, the units for w of t are degrees Fahrenheit, and the units for t is minutes. So the units for w prime of t, which is w of t divided by t, it's going to be degrees Fahrenheit per minute. So w prime of 12 tells us that the water is increasing, the temperature of the water is increasing at 1.017 degrees Fahrenheit per minute. This was a 2-point question, 1 point for the correct numerical answer, and 1 point for the explanation. Part B, use the data in the table to evaluate the integral from 0 to 20 of w prime of t dt, and ask us what does it mean. Okay, so this is a pretty simple one, right? So we have an integral and we have a derivative, right? So when we integrate the derivative, they both kind of cancel out. So what's going to happen is when we integrate w prime of t, like I said, the integral and the derivative will kind of cancel out, and we're just left with the original function. So w of 20 minus w of 0, okay? And we know w of 20, that is 71.0, and we know w of 0, which is 55.0. So when we do the subtraction, we get, let's see, 16, right? So this is this integral, and when we figure out what this means, let's focus on this part, w of 20 minus w of 0, right? What this really is this is just delta w, right? It's the final value of w minus the initial value of w. So this is telling us how much w changed between 0 and 20. And since w is the water of the temperature of the water in the tub, this delta w is telling us how much the temperature of the water in the tub changed from 0 to 20. So the correct units interpret the meaning. We'd say, all right, the water in the tub changed temperature by 16 degrees Fahrenheit from t equals 0 to t equals 20 minutes. Okay, this was another 2-point question, 1 point for the numerical answer and 1 point for the explanation. Okay, so part C, for t between 0 and 20, the average temperature of the water is this. Use a left Riemann sum with the 4 subintervals indicated by the data in the table to approximate it. And is this an overestimate or an underestimate? Explain your reasoning. Okay, so first of all, we need to evaluate this integral using a left Riemann sum with 4 subintervals, okay? So by 4 subintervals, what they mean is the first one goes from 0 to 4, the second one goes from 4 to 9, the third one goes from 9 to 15, and the fourth one goes from 15 to 20. Okay, so we're going to evaluate this integral, 1 over 20 integral 0 to 20, w of t dt. Okay, so let's figure this out, okay? So the first subinterval from 0 to 4, since we want to do a left Riemann sum, what we're going to do is we're going to take so we have 0 and 4, so we're going to take the left of these two, which is 0. We're going to take this value, 55, and we're going to multiply it by the difference in the t values. And so here's 0, here's 4, the difference between these two is 4. Okay, and for the second subinterval, we have 4 and 9. The left one is 4, so 57.1, times the difference between 4 and 9, which is 5, plus, and then the third subinterval from 9 to 15, we'll take the left, times the difference in the t value. Alright, hopefully you can see where this is going. And then finally, we'll take the left, times the difference in the t value. Okay, there you go. All we gotta do now is plonk this big boy in the calculator, and we get 60.79. Alright, so now we have to figure out, we figured out this this integral. Now we need to say, okay, is this an overestimate or an underestimate? Alright, so this is actually a tricky thing because it relies on a little tiny bit of data, a little tiny thing in the blurb of the question. Which one? Blurb of the question? I don't know, the words of the question, and that's the word strictly increasing, right? So if we were to draw a strictly increasing graph, so for example, there we go. If we were to do a left Riemann sum, you'd notice that we're missing these little triangle bits here and everywhere. So we're missing these little triangle bits. So our approximation is actually an underestimate because we're not including these little triangle bits, right? So what this means is that this approximation is an underestimate of the average temperature of the water over these 20 minutes. And for explanation, you'd say, okay, because W is strictly increasing, the left Riemann sum is an underestimate of the average temperature of the water over the 20 minutes. Okay, this was a 3-point question, 1 point for the left Riemann sum, 1 point for the answer, and 1 point for stating that it's a underestimate with a proper explanation. For t between 20 and 25, the function W that models the water temperature for the function W that models the water temperature has the first derivative given by that. Based on that model, what is the temperature of the water at time t equals 25? Okay, so we're dealing with t equals 20 and t equals 25, and we have this function. So what I'm going to do is I'm going to take that function and I'm going to integrate it between 20 and 25, right? Because I want the temperature of the water at 25, that's W of 25, right? So what's going to happen when I integrate W prime of t, remember when you do this, the derivative and then you go cancel out, and you just get W of 25 minus W of 20, right? Now we know the numeric value of this, so we can figure out the numeric value of this. So we'll solve for W of 25. It's equal to W of 20 plus the integral from 20 to 25 of W prime of t dt, right? We know W of 20, well, if we look at our table, W of 20 is 71, right? This is 71, and then we have the integral from 20 to 25 of W prime of t. What's the W prime of t? Well, between 20 and 25, we know it's equal to this, right? So I'll plug that in, 0.4 square root of t cosine of 0.06 t dt. And so if you throw this guy in your calculator, you get that W of 25 equals 73.043. Okay, this was a 2-point question, 1 point for the correct integrand and 1 point for the correct answer. And with that, we finished question 1. Let R be the region in the first quadrant bounded by the x-axis and the graphs of y equals ln x and y equals 5 minus x as shown in the figure above. So let's just label these graphs. This is ln x and this is 5 minus x, right? And then part A asks us to find the area of R, okay? there's two ways of doing this. The first way is splitting it right here where the two different lines intersect and finding each area separately and adding them both together. The second part, and the one that I'm going to show you, is using kind of turning everything sideways and looking at it from the y perspective. Okay? So what we're going to do to find the area of R, right, the area of R, the first thing we need to do is we need to figure out this distance, okay? And the way we're going to do that is we're going to use the formula top minus bottom, right? So the top is the distance from the axis to the far graph, or in this case it's going to be right minus left, I guess. But normally it's top minus bottom. Okay, so in this case, like I said, it's right minus left, so we're going from the axis to the right curve and the axis to the left curve. And if we do right minus left, that'll get us this leftover distance, okay? So what is right and what is left? So we're starting at x equals 0, and we're going over here, right? Since we're doing everything in terms of x equals something, I need to take each of these two graphs, or two equations, and solve them for x, okay? So I have y equals ln x. That's going to give me x equals e to the y. If I have y equals 5 minus x, that's going to give me x equals 5 minus y. Okay, so now I know from looking at these two lines, this long one goes from x equals 0 to x equals 5 minus y, right? So this goes from 0 to 5 minus y, so the right part is 5 minus y. Okay, the left one, it goes from x equals 0 to x equals e to the y, right? This is like the x distance that it goes out e to the y. So my left is e to the y. Okay, so now when I set up my integral, it's going to be the integral of right minus left, so 5 minus y minus e to the y. Okay, dy. And now for my intersection points, for the bounds for the integral, it's going to be starting at 0, right? Because we're starting at y equals 0. We go up to this intersection point, right? I need to figure out what this intersection point is. So to figure out this point here, what I need to do is I need to set the two graphs equal to each other. So I'll set 5 minus y equal to e to the y. When you put this in your calculator, you graph it and you solve, you get that y equals about 1.31, okay? And then from now on, I'm going to store this as the letter a. Okay, so whenever I reference a in the future, I'm going to be referring to this value, okay? That's what a capital A is going to refer to. So we're going to go from x equals 0, from y equals 0 up to this point y equals a, right? And we're going from 0 to a, and we're doing right minus left. If you put this integral in your calculator, it comes out to be about 2.986. Okay? That's that. And in terms of points, this was a 3-point question. 1 point for the bounds, 1 point for the integrand, and 1 point for the answer. Part B, region R is the base of a solid. For each solid, each cross-section each cross-section perpendicular to the x-axis is a square. Write but don't evaluate an expression involving one or more integrals that gives the volume of the solid. Okay, so how do we do this, right? So what we're going to do now is we're going to figure out basically if we're taking perpendicular to the x-axis, so we're going like this, right? If we want to make a bunch of squares, right, because they're saying it's a square, make a bunch of squares, and we make this like volume, right? What is the volume of that shape that we're creating? With all these 3D little squares, you add them all up, what do you get as your total volume? And the thing is, we have two different graphs, right? We have this ln x with 5 minus x. So the length of that square is going to be different based on which graph we're on, right? So what we'll do is we'll split it in half, and we'll deal with this section and this section separately. Okay? So we'll first deal with the left section. Since we're dealing with this left section, we're going to say, okay, so what is, what is, what is this distance, right? And you can say, oh, okay, it goes from y equals 0, and it goes till y equals ln x. So that distance is ln x, right? So the side, so this is for left, okay, the side equals ln x. And so what's the area of a singular square? If this side is ln x, and this side is ln x, the area is ln x squared, right? And then on the right side, the side is going to be equal to the distance from y equals 0 to y equals 5 minus x, right? So the side is going to be 5 minus x. So the area is going to be 5 minus x squared. That, okay? So we have the area of each square, each of these squares, right, depending on whether you're on this side, or the formula for their areas. All we got to do is now integrate them, okay? And the important thing to realize is that since we're dealing with this intersection point again, we need to figure out this x coordinate, because that's the point where we'll stop the integration for ln x and start the integration for 5 minus x, right? So to figure this intersection point, so to do that, we'll set ln x equal to 5 minus x. Solve this for x. You get x is approximately 3.693, and I'll save this as b. So whenever I reference b in the future, I'm talking about this value. Okay? So for our integral now, we're starting with this left side first. We're integrating, right? We're starting at x equals 1, okay? And we're going until we get to this point, which is x equals b. Alright? And what are we integrating? Well, we're integrating the area of a single square, which is ln x squared. Okay? This gets us the area of all of the squares in this part of the graph. Now we need to deal with this right part, right? So we're going to add the integral from b, because we're starting at b, and we're going up till, so it's 1, 2, 3, 4, 5. So we're going from b to 5, right? And then we're going to be integrating the area of the square inside of those regions, which is 5 minus x squared dx. Okay? So if we add both of these up, we'll get the squares in this region and the squares in this region. So that'll get us the total volume of the 3D solid generated with region R. Okay? So this is the final answer. We don't need to evaluate it, right? We need to get the equation for it. So we're done. This was a 3-point question. 2 points for each of these equations to find the area of an integer square, and then 1 point for putting everything together in your final answer. Part C. The horizontal line y equals k divides R into 2 regions of equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of k. Alright, so there's 2 ways of approaching this. I'm going to show you both ways. The first way is saying, okay, well, before I do that, let me explain what the problem is asking. So basically we have this region R, right, and it has some area, okay? And basically the thing is, if you choose some point and you basically split it at that point, you'll get one region here and another region here, right? So the question is, where are you going to split it so that the 2 regions have the same area? Okay? And so there's 2 ways of approaching this, like I said. The first way is saying, alright, in part A, we found out that the area is 2.986, right? So since each of these regions has half of the area, each individual region will have the area of 2.986 divided by 2, which is 1.493. Okay? So each of these regions will have an area of 1.493. Okay? So all you gotta do is say, if I integrate from, so remember in part A, we had the integral from 0 to a of 5 minus y minus e to the y dy, right? This time, we're not going all the way from 0 to a, this is a, right? We're going from 0 to this value k, right? K is this horizontal line. So instead of going all the way from 0 to a, we'll be going from 0 to k. So this time our integral would be the integral from 0 to k of 5 minus y minus e to the y dy. And this is going to get us that half area, right? So it should be equal to 1.493, which is half of the area. That is the first way of doing it, and that is the ugliest. I can draw better than that. Alright, so that's that's one method of doing it. The second method of doing it is going to be saying, okay, well, I know that this region, region 1 and region 2, both have the same area, right? So I'll write an equation for the area of volume of region 1, and I'll write an equation for the area of region 2, and I'll set those equal to each other since they have the same volume. So basically what that means is, since region 1 goes from 0 to k, I'll say the integral from 0 to k of 5 minus y minus e to the y dy. This is region 1, is equal to the integral from, so we're starting at region 2, right? We're starting at y equals k, that's the bottom, and we're ending at y equals a, that's the top. So we're going from k to a of 5 minus y minus e to the y dy. Right? This is also an alternate solution, and this one works as well. Okay? So you can choose whichever solution makes you feel the best, but they both work. You're both going to answer the question, which is, write we do not solve an equation involving one or more integrals whose solution gives the value of k. If you were to solve this integral out, you would get the value of k. Okay? This was a 3-point question, 1 point for the limits, 1 point for the integrand, and 1 point for the entire equation altogether. Alright, that's the end of question 2. Let f be the continuous function defined on -4, 3, whose graph consisting of 3 line segments and a semicircle is given above. Let g be the function given by g of x equals the integral from 1 to x of f of t dt. Find g of 2 and g of -2. Okay, so we'll start with g of 2, right? And so what we're going to do for that is we're just going to take 2 and plug it in for x. So it's the integral from 1 to 2 of f of t dt. Okay, how do we do this? Well, we're just going to take f of t, which is here, and find the area of it from 1 to 2. Okay, so 1 is here, 2 is here. We're going to find this area. Okay, as you can see, it's a triangle, right? So the area of the triangle is going to be the base, which is 1, times the height, which is, well, so if to figure out the height, you can say, okay, so if we go over by 2, we go down by 1. So if we go over by 1, we should go down by a half, right? So the height is actually going to be -1/2, because we're going down by a half. You can also do the thing where you find the slope between 2 points, but this is faster. And then of course we're going to take this and multiply it by a half to get the area of a triangle. So when we compute this, it comes out to be -1/4. That's the value of g of 2. Okay? Next, we'll talk about g of -2. It's the exact same thing. We just plug in -2 instead of 2. But now you see what's going on here is we have a bigger number on the bottom, right? That's kind of weird. So what we do to fix that is we can flip the order of the numbers if we just change the sign in the front. So from a plus here, it's going to go to a negative, and then instead of -2 on top and 1 on the bottom, it'll be the opposite, like that. So now all we got to do is figure out the area under the graph from -2 to 1. Okay, so let me erase this, and I'll color the new area, which is from -2 to 1. So -1, -2 is here. So we'll highlight that, and then -2 up till 1 is right here. So they want this area combined with this area, right? From -2, -1, 0, all the way to 1. Okay, so what's this going to be? Oh, we'll keep it. It's going to be negative, right? Don't forget that negative. For this triangle, it's going to be 1/2 times 1, which is the base, times 1, 2, 3, right? 1, 2, 3, which is the height. And then we're going to subtract the area of the circle, because the circle, or the semicircle, is under the x-axis. So we'll be subtracting, and then the semicircle, instead of pi r squared, we're going to do 1/2 pi r squared. So 1/2 pi, and in this case r is going from 0 to 1, so the radius is 1. So pi r times 1 squared. Okay, this is that. If you want to simplify it just a tad, you can say it's negative of 3/2 minus pi over 2, right? And that's good enough. We'll call that a day. These are our two answers. And in terms of points, this is a 2-point question. 1 point for the value of g of 2, and 1 point for the value of g of negative 2. For each of g prime of 3 and g double prime of g prime of negative 3 and g double prime of negative 3, find the value or state that it does not exist. Okay, so we'll start with g prime of 3, right? So we know that g of x is equal to the integral from 1 to x of f of t dt, right? That's given to us in the problem. Well, if we find g prime of x, what we're going to do is we're going to take the derivative of this, right? Taking the derivative of both sides to keep it equal. So this is equal to the derivative of the integral of f of t dt, and by the fundamental theorem of calculus, this is equal to f of x, right? The derivative and the integral kind of cancel out, and we just left with f of x, okay? So basically, g prime of x equals f of x, right? And then logically, therefore, g double prime of x must equal f prime of x, right? Okay? So now all we have to do is find g prime of 3, so g prime of negative 3, and that's just going to be equal to f of negative 3, right? And then g double prime of negative 3 is equal to f prime of negative 3. Okay, what are those? Well, let's see here. Negative 3 is going to be negative 1, negative 2, negative 3. As you can see here, at negative 3, we have this point here. Oh, that's in white. It's not there. With this point here. Oh, technical difficulties. We have this point here, which, as you can see, is equal to 2, right? To make it more obvious, you can see here we go across by 2. That's written. We go. We go across by 2, and we go up by 2, right? So when we go across by 1, we should go up by 1, right? So at 1, 2, negative 3, we're at 2. Okay? So this is equal to 2. And then as for g double prime of negative 3, that's equal to f prime of negative 3. That's going to be the slope at this section. And like we just said, when we go across by 1, we go up by 1. When we go across by 2, we go up by 2. So the slope is changing y over changing x, 2 over 2, which is 1. And you can see it's positive because we're going up. So the slope is positive 1, right? So there's our answer. G prime of negative 3 is 2, and g double prime of negative 3 is 1. This was a 2-point question, 1 point for each answer. Alright, part C, find the x-coordinate of each point at which the graph of g has a horizontal tangent line. For each of those values, determine whether x has a relative minimum, maximum, or neither at that point. Okay, so when we're looking for a horizontal tangent line, that means its derivative has to equal 0, right? That's when that's a horizontal tangent line. It's a flat tangent line. And then since g prime of x is equal to f of x, like we said in part B, this means that f of x has to equal 0. So we have to find all the points where f of x equals 0, and that'll tell us where g has a horizontal tangent line. Okay, so we see here we have 2 points where f of x is equal to 0. So there are 2 x-coordinates where g has a horizontal tangent line. We have x equals negative 1, right? Negative 1, and x equals positive 1, positive 1. And here, now we need to determine whether g has a relative minimum, maximum, or neither at those points. Okay, so if we're looking at relative extrema, right? We want to see, okay, what is happening at that point? What is the sign change? So basically, if the derivative switches from positive to negative, then we have a maximum. If it switches from negative to positive, then we have a minimum, right? And obviously, to switch from one sign to the other, it has to go through 0. So that's why we're looking at the points where it's equal to 0, okay? And at negative 1, we see that the derivative, of g, which is f, we see that f of x is positive beforehand, and then it becomes negative, right? So at x equals negative 1, f of x switches from positive to negative. So what that means is there is a relative max at x equals negative 1. But x equals 1 on the other hand, we see here we have a negative, or it's negative, it's under the x-axis, and at 1 it touches the x-axis, then it goes to negative again. So it never really comes on top here, it's always on the bottom of this x-axis. So it doesn't really switch sign at all, it's always negative. So we don't really have either a minimum nor a maximum at that point. So for your, you can explain this like f of x doesn't switch sign. So there's no minimum or maximum, right? Doesn't switch sign, so there's no relative minimum or maximum at x equals positive 1. Okay, this was a 3-point question. 1 point for considering g prime of x equals 0, 1 point for determining x equals negative 1 and x equals 1, and 1 point for the answer with an explanation. For negative 4 is less than x is less than 3, find all values of x for which the graph of g has a point of inflection. Explain your reasoning. Okay, so this is one of those times where one of those like step-by-step things that I like to do, those will come in handy. So we want to figure out where g has an inflection point. Okay? If g has an inflection point, what does that mean? Well, if g has an inflection point, that means that g double prime of x has to change sign, right? That's what an inflection point is, where the second derivative changes sign. And hang on a minute, we know from part B that g double prime of x, what's it equal to again? That's right, it was equal to f prime of x. So f prime of x changes sign. Okay, so we know that if g has an inflection point, then f prime of x changes sign. Okay, so all we got to do now is to figure out all the points where f prime of x changes sign. So that might be when it goes from increasing to decreasing, or decreasing to increasing, okay? So now we get to travel this graph and figure out all the points where it switches, okay? So here we can see it's going up, so f prime of x is positive. It's going increasing, up. Now it switches and becomes negative, right? So here's the point where it's switched from increasing to decreasing. And then it's going down, and then it stops here, and then it goes up again. So here you can see it switched from down to up. So there's another point, and then here it goes up, and then it stops, and then it goes down, right? So here's another switch, switches from increasing to decreasing. So f prime of x changes sign at these 3 points, right? I'm not going to write it out for the sake of time, but f prime of x switches sign at x equals negative 2, x equals 0, and x equals 1, right? So g has inflection points at those values. That's what you write down on your test. Okay, this was a 2-point question. 1 point for correctly identifying the 3 points where g has a point of inflection, and 1 point for proper explanation. That's the end of question number 3. Alright, question number 4. This question is honestly kind of unusual for AP tests, because this one's just like a lot of straight calculations, and usually AP questions are more like kind of evaluating stuff and like critically thinking, but this is just kind of straight math. Like, I've never ever thought that I would see a question that just asks you to straight up evaluate an integral like this. But, you know, whatever. So, question 4. The function f is defined by f of x equals the square root of 25 minus x squared for x between negative 5 and 5. Part A asks you to find f prime of x. Okay? So the first thing to know is that the derivative, right, this is the same thing as f prime of x. This is the same, right? The derivative of square root of x is 1 over square root of x times 1/2. So 1 over 2 square root of x. Okay? So if we want to find f prime of x, and f of x is the square root of 25 minus x squared, then, well, f prime of x is just going to be 1 over 2 times the square root of 25 minus x squared, but we're not quite done yet. Because this thing in here is a compound function, we need to take the derivative of it per the chain rule, okay? So we have this, now we need to, because of the chain rule, multiplied by the derivative of the inside function, which is 25 minus x squared. So the derivative of 25 minus x squared is negative 2x, right? So negative 2x, if we simplify that a bit, the 2's will cancel, we'll get negative x over square root of 25 minus x squared. Okay. This was a 2-point question, 2 points for the correct answer. Alright, part B, write an equation for the line tangent to the graph of f at x equals negative 3. Alright, so whenever you see they ask you for a tangent line, you need to always write down 2 things. You write down point and slope. Okay, so for point, we need to write down the point that is, that we're interested in. So since we're at x equals negative 3, the point is going to be negative 3, comma, f of negative 3, right? That's the point. And then our slope is going to be the slope of that point, which is the derivative f prime of negative 3. Okay? So all we've got to do now is evaluate f prime of negative 3 and f of negative 3, okay? So f of negative 3, well, that's going to be, we plug in negative 3 in for here, with the square root of 25 minus negative 3 squared, which is the square root of 25 minus negative 3 squared is positive 9, so it's 9, which is the square root of 25, well, okay, it's going to be 16, and the square root of 16 is 4, right? So f of negative 3 equals 4, so this point is negative 3, comma 4, okay? Now I want you to write f prime of negative 3. F prime of negative 3, well, I'll do it in a different color actually. F prime of negative 3, well, first I'm going to write out the equation for f prime of x, okay? So from part A, we said that f prime of x was negative x over square root of 25 minus x squared. Okay, now to find f prime of negative 3, we need to plug in negative 3 into x. So f prime of negative 3 equals negative of negative 3 over the square root of 25 minus negative 3 squared. Okay, scroll down. Okay, this is equal to, so the negatives will cancel, which get positive 3 over, and like we said before, this thing is equal to 4. Right, so this is equal to 3/4. So f prime of negative 3 is equal to 3/4. So now that we have the point and the slope, we can put this together. In our point slope form, we have y minus y1, so y minus 4, equals the slope, which is 3/4, times x minus x1, it's x minus negative 3, so it's x plus 3. Okay? And that is the equation of the tangent line. This is a 2-point question, 1 point for correctly finding the value of f prime of negative 3, and the second point for the correct equation of the tangent line. Part C. G is defined as the function g of x equals this piecewise function, where from negative 5 to negative 3, it's f of x, and from negative 3 to 5, it's x plus 7. And we're asked, is g continuous at x equals negative 3? So at this point, we're search is g continuous, okay? And to use the definition of continuity to explain our answer. So if it's continuous, right? If it's continuous, we'll have the left side and the right side limits both approaching the same value, and the value that it's approaching is going to be the actual value at that point. So expressed, more mathematically, it is continuous if the limit as x approaches negative 3 from the left of f of x equals the limit as x approaches negative 3 from the right of f of x. Oh, nope, sorry, that's my bad. It's supposed to be g of x. I apologize for that. G of x. So yeah, we're looking at g of x, right? It's asking if g is continuous at x equals negative 3. So g of x, and if this is actually equal to g of negative 3. Right? If all of these three things are equal, then it's continuous. Okay? So let's take this one at a time. We'll start with the limit as x approaches negative 3 from the left of g of x. Okay? So from the left, we're looking at this part, right? Because this is what g of x looks like on the left of negative 3. looks like f of x. So what this is this is the limit as x approaches negative 3 from the left of f of x. Okay, and so as f of x, as x gets closer to negative 3, then x squared is going to get closer to 9, right? Like we said in the other part, 3 squared is 9, negative 3 squared is 9. So as x gets closer and closer to negative 3, x squared is going to get closer and closer to 9. So this is going to be the square root of 25 minus 9, which is 4, like we said before. So this is equal to 4. Now let's look at the limit as x approaches negative 3 from the right of g of x. Well, that's going to be, on the right, g of x is just x plus 7, right? The right of negative 3 is just x plus 7. So this is the limit as x approaches negative 3 from the right of x plus 7, which is negative 3 plus 7, which is 4, okay? The final thing to ask, what is the value of g of negative 3? Alright, if we look here, we see that it's equal to f of x for negative 5 is less than or equal to x is less than or equal to negative 3. That's the key, this or equal to part. Because that means g of negative 3 is equal to what happens whenever we plug in negative 3 directly into x. So if we plug in negative 3 into x, we'll get 25 minus 9, which is 16, and the square root of 16 is 4. So if we plug in negative 3 directly into here, we will get f of negative 3, which is 4, right? So as you can see, I'm just going to copy paste this. Since all of these are equal to 4, we can say that g of x is continuous at x equals negative 3. Okay, and there is our answer. This was a 2-point question. 1 point for looking at the left and right sided limits individually, and 1 point for a correct final answer with the explanation. Part D, find the value of the definite integral from 0 to 5 of x times the square root of 25 minus x squared dx. This is probably, like I said earlier, the most straightforward question they will ever ask you, ever. So I guess cherish it. You know, it's a rare thing. So this integral, x squared root of 25 minus x squared, this is a classic u-sub situation, okay? How can I tell it's a u-sub situation? Well, there's a x squared, and there's a x which is 1 power less, right? So what we're going to do for the u-sub is we're going to say, okay, x is, u is going to be this thing that's inside here. So u is 25 minus x squared. If we take the derivative, we'll get du dx. It's going to be negative 2x. Okay, now I'll bring the dx over to the side. Now I'll get du is negative 2x dx. And since over here I have a x dx, I want to have an x dx over here too. So we'll take this negative 2 and bring it down. So du over negative 2 is equal to x dx. Okay? So what I can do is I can take this x dx, I can replace it with du over negative 2. So to make it a bit more clear, maybe this will help you. I can rewrite this first thing. I can rewrite this as 25 minus x squared times x dx. And then, and now it's pretty obvious, I can take this x dx and replace with this du over negative 2, since they're equal, right? So this becomes the integral, hold off on the limits for now, and then square root. Now remember, 25 minus x squared is equal to u, right? So instead of writing square root of 25 minus x squared, since we're turning everything into u, I'm going to have square root of u. And then x dx gets replaced with du over negative 2. Now for the bounds. We're not going to keep 0 and 5 because those are the bounds for x, not the bounds for u. So to switch the bounds over to what we want, the bounds for u, we're going to take 0 and 5 and plug them in here for x and see what comes out of for u, okay? So if I plug in 0 in for x, I'll get u is equal to 25 minus 0, so 25. And if I plug in 5 for x, I'll get u is equal to 25 minus 25, which is 0, okay? Now, this may look a little bit weird, so going from a bigger number to a smaller number. Remember, you can switch the bounds of the integral if you switch the sign in front. this is going to be negative integral from 0 to 25 of square root of u du over negative 2. Okay, the negatives will cancel, and I can take this 1/2 and pull it out completely. That's the integral from 0 to 25 times 1/2, that is, of square root of u du, okay? Now all I have to do is evaluate this, right? So the first thing we're going to do is rewrite the square root as u to the 1/2 du, and now we can do our standard integration procedure, which is adding 1 to the exponent and multiplying by the reciprocal, right? So if we add 1 to the exponent, we get 3/2, and then we multiply by the reciprocal, which is 2/3. So this is equal to 1/2 times u to the 3/2 times 2/3. Okay? It's being evaluated from 0 to 25. Okay? So the 2's will cancel, and we're just going to get u to the 3/2 over 3 from 0 to 25. Okay? So we'll plug in our numbers. Plug in 25 first. We'll get 25 to the 3/2 over 3 minus 0 to the 3/2 over 3. Now you can call it a day here if you want to just circle this, but I'm just going to go a tiny bit further. This is just 0 because 0 to the anything is 0. 25 to the 3/2, well, the square root of 25 is 5, and 5 cubed is 125. So this is equal to 125 over 3. But honestly, if I was in a real test in this situation, I'd probably just leave it as this. Okay? Either way, your answer is 125 over 3, or 25 to the 3/2 over 3. Same thing. That's the answer to that integral they wanted. Okay? This is a 3-point question. 2 of the points come from successfully completing the antiderivative, or the integral. That's this part here. And then 1 point for the correct final answer. That concludes question number 4. The rate at which baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, its weight is 20 grams. B of t is the weight t days after it's weighed. It's equal to this. Is the bird gaining weight faster when it's 40 grams or when it's 70 grams? Okay, so we're looking at B of t, right? B of t is the weight of the bird. Okay, so if we want to look at how quickly the bird is gaining weight, we're looking at how quickly the weight is changing. So looking at the rate of change of the weight with respect to time. That's dB dt. Okay, so we're looking at dB dt. Is it gaining weight faster when it's 40 grams or when it's 70 grams? So we're going to look at, is dB dt bigger? So is the speed at which it's gaining weight bigger when it's 40 grams or when it's 70 grams? So we'll look at dB dt when t is equal to 40 and dB dt when t is equal to 70. And we'll say which one of these is bigger. Okay, when it's equal to 40, it's going to be 1/5 times 100 minus 40. Well, 100 minus 40 is 60. 60 over 5 is 12. Okay, so at 70, it's 1/5 times 100 minus 70. 100 minus 70 is 30. 30 over 5 is 6. Okay, so as you can clearly see here, dB dt is bigger when t equals 40 compared to when t equals 70, right? 12 is greater than 6. So it's gaining weight faster when it weighs 40 grams. In your explanation, you'd say dB dt when t equals 40 is greater than when t equals 70, so the bird is gaining weight faster when it weighs 40 grams. This was a 2-point question. 1 point for including dB dt as part of your process, and another point for the correct final answer with an explanation. Part B. Find the second derivative of b in terms of b. Use the second derivative to explain why the graph of b cannot resemble the following graph. So this graph here is wrong. It's a wrong graph, and they're asking you use the second derivative to show why it's wrong. Okay? So the first thing we'll do is we'll actually start by finding the second derivative. Then we'll deal with this whole graph business. Okay? So the first thing we're going to do is say, okay, what is the second derivative of b? So we have the first derivative. So what we're to do is take the derivative of it again to get the second derivative. So the second derivative is the first derivative with respect the derivative of the first derivative, and then this is equal to this. So basically we're taking the derivative of our dB dt. Right? So it's going to be, this is going to be a 1/5. Right? And the derivative of 100 is 0, and the derivative of negative b is negative dB dt, which is negative 1/5 dB dt, but we're not done yet, right? Because they're asking us what is it in terms of b, right, in terms of b, but we still have a dB dt here. This isn't completely in terms of b yet. So how do we get dB dt in terms of b? Well, we know that dB dt is equal to 1/5 times 100 minus b, so we'll just take this guy and put it back in there. So this is negative 1/5 times 100, sorry, no, it's negative 1/5 times 1/5 times 100 minus b. That's not a b. Here you go, 100 minus b. Right? So this 1/5, negative 1/5 comes from here, and then this 1/5 times 100 minus b comes from plugging in dB dt for this value, okay? So we have this, simplifying this a little bit gets us negative 1/25 times 100 minus b. Okay? So that's our final dB dt, that's our final d squared b dt squared, second derivative, and all we got to do now is figure out why this tells us that this graph is wrong. Okay, so when I think of the second derivative and I think of the graph, the first thing that should come to your mind is concavity, right? Because the second derivative tells us all about the concavity of a graph, all right? So notice here that we're going from between t equals 20, sorry, we're going anywhere between b equals 20 and b equals 100, right? So if we plug in a b here, it can be anything from 20 to 100, okay? And notice that that means this thing will either always be positive or 0, or it can never be negative. And so since there's a negative over here, if b is less than 100, this thing's always going to be negative, right? So for any b less than 100, it's going to be negative. And even if b is 100, it's going to be equal to 0, right? So this guy is never positive for b, well, I'll be more specific. I'll say 20 less than equal to b, less than equal to 100, right? So it's never positive, it's always negative or 0. And if we think about concavity and the sign of the second derivative, we say, okay, if it's concave up, then it's positive. If it's concave down, then it's negative. Since this graph is never positive, right? Since our second derivative is always negative or 0, it's never positive, then our graph must be always either flat or concave down, right? It's never going to be concave up, okay? Because the second derivative is never positive. So in this graph here, however, we see that in this first section up until this inflection point, we see that the first derivative, sorry, the second derivative is positive because it's concave up in this section, right? We said, oh, no, it's never positive, so it's never concave up, right? But in this graph, a portion of it is concave up, so that's why the graph is wrong. It's always going to be concave down. So in reality, the graph would look something like this, right? Something like that. That's not the best drawing, but you get what I'm trying to say. It's always concave down, never concave up, okay? So that's why that's why the second derivative tells us that the graph of b cannot resemble its following graph. So for explanation, you can say the given graph is like partially concave up, right, until the inflection point. It's concave up partially, and that is wrong because it should never be positive, right? So yeah, I think I've said that enough times. That's part B. This was a 2-point question, 1 part for the second derivative and 1 point for the explanation of why the graph cannot look the way it is shown. Part C, use separation of variables to show that to find y equals b of t with the particular solution to the differential equation with the initial condition b of 0 equals 20. Alright, so you should be, again, like I always say, you should be jumping in joy because these are my favorite type of questions because they're always predictable, they're always easy, they're always a lot of points. They're usually like 5 or something points. This particular one is 5 points, okay? So let's get started, right? we want to find the solution to the differential equation with this initial condition. So we'll start with dB dt equals 1/5 times 100 minus b. Now we'll bring all the b's onto one side and all the t's onto the other side, right? That's called separation of variables. So 1 over 100 minus b dB equals 1 over 5 dt. Okay, so we've brought all the b's onto one side and the t's onto the other. And now what I'm going to do is I'm going to integrate both sides. And we already have a dB and a dt here, so it's just a matter of simply integrating. Okay, this guy, since there's a -1 in front, this is not going to be the natural log of 100 minus b. It's going to be the natural log of it's going to be negative natural log of 100 minus b, because of that negative coefficient there. Okay, this is like 100 minus 2b, then it would be minus 1/2 natural log of 100 minus 2b. Okay, so basically you're dividing by that coefficient there. In this case, that's -1. So this is equal to the integral of 1/5 with respect to t, which is 1/5 t. And then we only need to include 1 plus c for these kind of problems. Okay. The next thing we're going to do is we're going to solve this for b. So the first thing I'll do is I'll bring the negative to the other side. ln 100 minus b equals negative 1/5 t plus c. So this c is kind of like, it'll like absorb kind of anything you throw at it. It'll absorb the negative sign. It'll absorb multiplication or division or whatever. So it just kind of takes it and it doesn't change. It's always just some constant c. It might be a different this c might be like different numerically than the c up here, but they're both constants. Okay. Next thing we're going to do is we're going to get rid of this natural log by taking e as the base for both of these. Right. So these will cancel out and we just get 100 minus b. This is going to be e to the negative 1/5 t plus c. Okay, next thing I'll do is I'll say, okay, I can split this up, and I'll say it's going to give me e to the negative 1/5 t, and then e to the c, right? I split this up because it's an addition there. And another thing you can realize is that e to the c, that's just another constant c, right? A constant raised to the power of a constant is a constant. Plus. Okay, so now that I have this, I just need to solve this for b, right? So I'll take this b, add it to this side, and subtract everything else onto this side. So it'll give me b equals 100 minus c e to the negative 1/5 t. Okay? Now, we'll do our initial condition, which is, if you look up here, b of 0 equals 20. So we'll take 0, 20, plug in 0 for t and 20 for b, and we'll see what c is equal to. 20 is equal to 100 minus c e to the negative 1/5 times 0, right? So this whole thing, since e to the 0 is 1, goes away to 1, and we get 20 equals 100 minus c, so c equals 80, okay? So we'll take this original equation for b here, and I'll plug in 80 in for c, so we'll get b equals 100 minus 80 e to the negative 1/5 t. And with that, the problem is solved. And like I said, this one was 5 points. You get 1 point for separating the variables, 1 point for correctly integrating, 1 point for including a plus c, 1 point for using the initial condition, and 1 point for the correct final answer. All right? That concludes question number 5. Question number 6. For t between 0 and 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t is equal to cosine of pi over 6t. The particle is at position x equals -2 at t equals 0. For t between 0 and 12, when is the particle moving to the left? Alright, so if the particle is moving to the left, what that means is that its velocity is negative, right? So we want to look at all the places where it's moving left, which means its velocity, which is v of t, is negative, it's less than 0, okay? So first, to do that, we'll figure out where it is equal to 0, okay? So if we take v of t equal to 0, which means cosine of pi over 6t is equal to 0, And now remember, cosine is like a function that goes up and down and up and down. So it's going to have infinite places where it's equal to 0, right? But we're looking at, for all the t's, only between 0 and 12. So that puts a limit on our function, okay? So now you have to think about, all right, what cosine of what equals 0, right? Well, let's see, cosine of pi over 2 equals 0, right? Cosine of 3 pi over 2 equals 0. Cosine of 5 pi over 2 equals 0. Cosine of 7 pi equals 2 over 0. And so on and so forth, right? Those are all equal to 0. So we're thinking, okay, what values of t can I plug in to get these numbers, right? So if I plug in t equals, so to get pi equals 2, pi over 2, we need to plug in t equals 3, right? So I get 3 pi over 6, which is pi over 2. So we can plug in t equals 3 to get pi over 2. And if we want to get 3 pi over 2, we'll have to plug in t equals 9, right? That's 9 pi over 6, which is 3 pi over 2. So we'll plug in t equals 9. Okay? If we want to get 5 pi over 2, we'll have to plug in t equals 15, right? 15 pi over 6, which is 5 pi over 2. But the problem is, 15 is outside of the interval from 0 to 12, where we're supposed to be. So we can kind of ignore these other values because we're only focused on these two. Because here, the value of t becomes greater than 12. Okay? So these are the only values that we're looking at. And then to figure out, all right, when is it moving to the left, we'll take a little number line with the velocity. And we'll start with 3 and 9. And then we'll add in our endpoints, 0 and 12. Okay? So in this, 0 and 12, right? So in this region, we'll figure out, all right, is the velocity positive or negative in each of these three intervals, okay? So I can take a random number for t between 0 and 3, and I'll ask myself, all right, is it negative or positive, right? Say, for example, I do, I don't know, t equals 1, right? Cosine of pi over 6, that's in the first quadrant, so it's going to be positive, okay? And let's say I do a number between 3 and 9, let's say I do 6, right? Cosine of pi is negative 1, so that's a negative number in between 3 and 9, all right? And then between 9 and 12, let's say I plug in, I don't know, 11, right? Cosine of 11 pi over 6, that's in the fourth quadrant, that's going to be a positive cosine, okay? So you notice here that the only region where the velocity is negative is between 3 and 9, okay? So we'd say, oh, the particle is moving to the left when 3 is less than t is less than 9. Okay, this was a 2-point question. 1 point for realizing that we had to set the velocity equal to 0, and another point for the correct answer. Alright, part B. Write, but do not evaluate, an integral expression that gives the total distance traveled by the particle from t equals 0 to t equals 6. Okay, so this is a question where you need to know the difference between distance and displacement. So if we're looking at distance, okay, we're looking at the integral of the absolute value of velocity. And if we're looking at displacement, we're looking at the integral of just velocity. Okay, so since we're looking for, in this situation, we're looking for distance, we're taking this formula. So the answer is the integral, since we're going from time equals t equals 0 to t equals 6, the bounds for the integral is 0 and 6, and we'll have the absolute value of the velocity, which is cosine of pi over 6t dt. Okay? That's the integral expression that we want, and this is a simple 1 point for the correct answer kind of problem. Part C, find the acceleration of the particle at time t. Is the speed increasing, decreasing, or neither at time t equals 4? Alright, so remember, acceleration is the derivative of velocity. So to find the acceleration at time t, we need to take the derivative of the velocity function. Okay, so we'll find a of t. It's going to be the derivative of this. Remember, the derivative of cosine is negative sine, right? So the derivative of this is going to be negative sine of pi over 6. But since the inside thing is a composite function, we have to multiply this by the derivative of the inside function per the chain rule. So we're going to multiply this, this should be pi over 6t. So we're going to multiply this by the derivative of pi over 6t, which is pi over 6. Okay, so if I rewrite that, they'll get negative pi over 6 sine of pi over 6 t. Okay, that's our acceleration at time t. And now we're also asked, is the speed increasing or decreasing at t equals 4? Now, when they talk about speed, remember, speed is different than velocity, okay? If we're looking at is the speed increasing or decreasing or neither, we're looking at what is the sign of the velocity and the sign of the acceleration. So at t equals 4, we're going to have to find v of 4 and a of 4, okay? v of 4 is simple, we just plug in 4 in for there. So we'll get cosine of 4 pi over 6, which is cosine of 2 pi over 3. And then, what is cosine of 2 pi over 3 again? We have to go all the way back to those words that we learned in pre-calc that we might have forgotten, right? Unit circle, reference angle, all those old words from like elementary school, right? So basically, remember, so cosine of 2 pi over 3, well, 2 pi over 3 is in the second quadrant, so it's going to be a negative, because cosine is negative in the second quadrant, and the reference angle is pi over 3, so this is going to be negative cosine of pi over 3. What's cosine of pi over 3 again? You should memorize that. It is equal to 1/2, so this is negative 1/2, okay? Acceleration at 4 is going to be negative pi over 6 times sine of 4 pi over 6, which is negative pi over 6 sine of 2 pi over 3. And now, again, remember, 2 pi over 3 is in the second quadrant, but sine is positive in the second quadrant, right? So since the reference angle is pi over 3 still, this is just negative pi over 6 times sine of pi over 3. Sine of pi over 3 is square root of 3 over 2, so this is negative square root of 3 pi over 12. Okay? Okay, and so we're looking at the sign of both of these, right? We know, so the velocity is negative, right? It's negative, and our acceleration is also negative. So since the velocity and the acceleration have the same sign, then the particle is actually speeding up. Even though they're both negative, it's still speeding up. So what you'd say is that because the velocity and acceleration have the same sign at t equals 4, the particle is speeding up, right? It's speeding up in the negative direction, sure, but it's still speeding up. Okay, so this is a 2-point question. 1 point for finding the value of the acceleration, and for the equation of the acceleration, and 1 point for the correct answer with explanation. Alright, part D, find the position of the particle at time t equals 4. Okay, so basically, to do this, we have to know that if we integrate our velocity, right, if we integrate our velocity from a certain endpoint, from one endpoint to another endpoint, we'll get the position, the change in position, okay? If we do this, we'll get the position at 4 minus the position at 0, okay? This is the key thing to realize to solve this problem, because remember I said the integral of velocity is displacement, right? Displacement is the delta x. That's the displacement, okay? So we have this, and now what we've got to do is we've got to take this and use this to find the position of the particle at time t equals 4, right? X of 4 is the position at 4, and x of 0 is the position at 0. So we can rearrange this to solve for x of 4, position at 4, and we see that it's x of 0 plus the integral from 0 to 4 of v of t dt. You know, if you're taking physics, this should look very similar to one of the UAM equations. Okay? So we're going to find a position at t equals 4. We know that x of 0, that's the position at 0, that is negative 2, because they told us it's at position x equals negative 2 at time t equals 0. So x of 4 is equal to negative 2, which is x of 0, plus the integral from 0 to 4. What's v of t again? Well, it's cosine pi over 6 t dt. Okay? So now after you got to integrate this by hand, and we'll do you can do u substitution, but in this kind of thing, you kind of want to you want to try to do this by hand, or by your mental ability if possible. Okay, so if you integrate this, you should remember that the integral of cosine is positive sine, so we'll start with a positive there. And then if we integrate this, we'll get sine of pi over 6t divided by pi over 6, so times 6 over pi. Okay? And then this thing is going to be evaluated from 0 to 4. So if we plug in 4, we'll get negative 2 plus 6 over pi times sine of, if we plug in 4, we'll get 4 pi over 6, which is 2 pi over 3. And then if we plug in 0, we'll just get sine of 0. Right? So this is going to be negative 2 plus 6 over pi. Sine of 0 is 0, so we just kind of ignore that part. Sine of 2 pi over 3, what's that again? Oh yeah, from earlier on we said it's square root of 3 over 2, so this is times square root of 3 over 2, so it's negative 2 plus 3 square root of 3 over pi. Okay, and that is the position of the particle at time t equals 4. Not that bad, right? This was a 3-point question. 1 point for correctly computing the antiderivative, 1 point for correctly realizing that x of 0 is equal to negative 2, and 1 point for the final answer. That concludes question 6, and with that, the 2012 AP Calculus exam. I hope you liked this video, and I'll see you next time.